So we'll start the session of today. The next speaker is Jake. So please go ahead.
All right. Hey, everybody. I'm Jake Scruggs. Everybody hear me good? Excellent. I'm here to talk about speedy tests, something that I've been thinking about for quite some time. I was a consultant for 6 years, which meant I got into a lot of interesting code bases. And the one thing I noticed is that everybody completely was used to whatever the time of their test suite took. So you'd show up and maybe they had a test suite that ran in under 10 seconds, or they had a test suite that ran in 5 minutes or 30 minutes or 60 minutes. And everybody would be like, what are you going to do? That's how long the test suite takes. And it just sort of created these completely different teams, right? Like teams where the test suite ran really fast, like you had all this sort of smooth functioning sort of awesomeness going on, and teams where, you had 30-minute test times, a lot of people did a lot of browsing on the internet, and it was sort of a different sort of team. So that's me in the photo. That's my lovely wife. I was a physics teacher in 2004. I somehow talked my way into Object Mentor, and I did an apprenticeship. Then I worked at ThoughtWorks for 4 years. Then I worked at Optiva. Now I'm at a place called Backstop Solutions. We build frameworks for creating websites for hedge funds and such. I'm also known as the metric foo guy, which I'll talk a little bit about later. Moving on. So slow test suites are vampires that drain your team's morale, right? But you don't really even notice that they're being drained at the time, right? Because who doesn't like to surf the internet or check out Failblog or whatever? It seems like everything's kind of cool and people are adjusting to it, and very often people do things like, oh, well, I use auto tests, so I only run the stuff that I need to run, but you know how that works, right? Like sometimes the things that you think you don't need to run, you actually really do need to run. And you just create all these like crazy problems, right? Like arguments about fault never really happen if you have a fast test suite. But they happen all the time when you have a slow test suite, right? You have a 10-minute test suite, you check in to continue, and the continuous integration kicks off. Now, 3 other people check in, 4 other people check in. So now the next time continuous integration runs, it's got like 4 or 5 check-ins, and the build breaks. And I've been on teams where like the build breaks, and I go, okay, the build breaks. Nobody cares. So then I go to continuous integration, and I go, okay, there was one of these 5 people, right? So I sent out an email, hey, one of you guys broke the build. And then everybody goes, meh, it wasn't me. And they move on and keep working, right? And then like now I have to be the jerk, right? I have to like kind of go through and then publicly out somebody and say like this was your fault and you're going to fix it. And that's not a good situation. And a lot of times most people don't have a person on the team who wants to play that role, right? Like I'll do it because I don't mind looking like a jerk, but there's a lot of teams who are just like, and then like the build just sort of fails randomly forever. It's like I was saying, it's like a frog in a slowly boiling pot of water, right? You don't really notice that things are getting worse and worse and worse. Like I was on a team where we had a 10-minute test suite, and then 2 weeks later we had a 20-minute test suite. And it wasn't because somebody checked in a 10-minute test. It was because a lot of people checked in 10-second long tests or 1 second long tests or even half a second long tests, right? You get enough of those things that take way longer than they should, and all of a sudden you don't have one thing you can point at and say, let's fix this. You have a whole bunch of things to fix. But the worst problem is that it makes you hate testing. Like when I first got into this, I loved testing because all the problems that I had when I was hacking on my TI-99 4A were that I would write and write and write and write as much code as possible, and I'd hit run at the end, and then I'd spend a week or two debugging. Test-driven development is great, right? Because you just sort of know right after you write the test and run it if it's working or not, and then you have something to sort of put your back against to say like, okay, at least I know this stuff's working. The bug has to be over here somewhere. That all goes away if you have a slow-running and faulty test suite. If your test suite is not reliable and speedy, people just start resenting it, and they start resenting testing, and it becomes a chore. Right? It's like, oh man, like I wrote all the code, but now I have to go write the tests. Well, first of all, you're doing it wrong. You should have wrote the tests first. But second of all, like, it's sort of a bad way to look at things. Okay, so there's two solutions I'm going to discuss, or two categories of solutions I'm going to discuss. The first category is going to be solutions that you don't have to change your bad habits, right? So you've got a slow-running test suite. You may want to make it go faster. Well, I've got some ways we can make it go faster without having to go into each individual test and change things. So use all your cores, right? It's no secret that computers are no longer getting really much faster. What they're doing is getting more and more cores, right? This laptop here sort of has 4 cores, which is kind of cool, right? But like if I don't use them, and very often I don't when I'm running Ruby, then it's kind of silly. So there's a whole bunch of solutions. This is like all I know about that's sort of under active development. I'm sure there are others. Parallel tests, I've used that. It's pretty cool. One of the things about it is that you have to set up a database for every core that you have, which is interesting. Like if you're using like a 16-core Linux machine, you might have to have 16 databases for that thing. So, and every time you want to migrate, don't forget to migrate all 16 of those databases. So some of these multi-core solutions can be a little rough on the maintenance part, but the great thing about them is they totally free you up from having to make sure your tests behave like good citizens, right? Because if you have a bunch of tests that sort of are grabbing at the same resources, then using one database is not going to work very well if you have multiple cores. There'll be a whole bunch of deadlocking. But if you're using multiple databases, then you don't have to worry about that. So it's a bit of a trade-off. The uneven split thing I keep listing next to all these guys refers to the fact that some of these guys do sort of an intelligent, artificial intelligence sort of thing, and they look at they track the length of the test or how long it runs, and then they try to distribute the tests amongst the cores so that everything works out nicely. If you don't do that, what often happens is you sort of do a naive thing. You say, well, I have 4 cores and I have 100 tests, so everybody gets 25 tests. Done. Except that what if you give 10 of those 25 are the longest running tests you have to one core? So then what you have is all 3 cores finish, and then you're waiting for that last core, and it kind of sucks, right? Because you're like, damn it, the whole point of using cores was to do parallelization. So a number of these solutions like parallel test, SpecJur, deep test, all sort of use, I was naming the wrong things. A number of these guys do an uneven split. Some guys that do are deep test and Hydra. These guys actually keep track of how long the tests take and do just a much more equitable splitting up amongst cores. Hydra is a pretty interesting newcomer on the scene. It's really been designed to be like the simplest possible thing to set up. So it uses one database, it splits on duration, it can do SSH and rsync, so you could actually, you don't have to do this, but if you want to, you could have like a couple of machines living somewhere in the office, and then when you run tests, it'll just go, oh, hey, machine, run some of my tests for me, and it'll spool them off to other machines in your office, which is pretty cool. I know a number of teams that do that. They just have machines that are devoted to running tests for the developers, which is a handy thing. What else could I say about these guys? They all have different sort of pros and cons. It's sort of an exercise left for the reader to go through and figure out which one's right for you. I would say deep test is probably the most mature of all these guys. It's been around forever, but it also is the most intense in terms of setup. But you really know it's going to work once you get it set up, right? Because you've learned all this stuff about sockets and good stuff. Whereas Hydra really tries to make it easy. On the other hand, since Hydra uses one database, it's not very good for a lot of applications. For instance, I can't really use it on my application right now because we have a number of tests that what they do is they lock up the database to do this sort of big publishing stored procedure thing. which sucks, but it's a really good test. It's caught a lot of bugs, like a lot of really bad bugs that would have gone out to production. So I have to keep these tests around, but they lock up the database, and so multiple cores trying to use the database while this is happening, basically everything blows up and it doesn't work. So experiment and try what you can. Let's talk about I/O for a little bit. There's this thing called journal writeback, which is really good if you have a hard crash on your system, right? It figures out like what's been written and what hasn't been written to disk, and extremely useful, right? Like if you go down hard in production, you can recover your transactions. People have purchased things. You want to get that right. However, there's a bit of a time cost for it. And when you're running tests, keep in mind, you don't care at all about consistency or recoverability, or, well, you do care about consistency, but you don't care about like being able to start up the test at the same place later. You're just going to run the whole suite again, right? So if you turn this off, what you do is you save yourself a bit of I/O time. Linux is pretty easy to do. Macintosh, not so much. I've said this, but I'll say it again. Do not turn off in production. There's a very good reason it exists. However, A-time, not so much. It's sort of this thing that's kind of been like hanging around in Unix forever. It's access time, right? And what it does is it turns every read into a write, right? Because every time you read something, you've accessed it. So now you have a write going on. And this, if you're doing a lot of I/O, can lead to problems. The problem being you have slow tests. So you can turn it off. There's a couple of resources for how to turn this off, and it saves you some I/O churn. Sort of your mileage will vary. It depends on your test suite, like how much I/O stuff you're doing. Also, if you've optimized in other areas, you may be now hitting the I/O as your bottleneck, right? Like if you did this right away, you might not notice speed changes. However, as you start to optimize in different ways, as you start to say, oh, okay, I'm going to use lots of cores, now all of a sudden maybe your bottleneck is somewhere else. Fast context is an interesting thing if you use shoulda. So shoulda has all these blocks, right? And you have a setup, and then you have a bunch of individual little shoulds, right? Individual little tests. Fast context can kind of mash these all together, so it runs the setup once and then runs all the assertions together. So you don't have to like loop through this a bunch of times. The nice thing about that is you don't have to do the setup a bunch of times. The bad thing is if you don't write atomic tests and they start altering the thing that you set up, right? The setup is supposed to happen every time. If you alter the thing that you've set up, then like the third test can fail. So depending on how you write your test, this could be a good or bad thing. I know people who swear by it. They're like, oh, I cut my test time in half. And other people are like, ooh, we couldn't get it to work. These things, these sort of solutions where you don't have to change your tests and make them better are all kind of dependent on like how it works out for you, because you might have tests that just don't work with this. Okay, now I should talk about Ruby Enterprise Edition. I thought this had no chance in hell of working, and it completely proved me wrong. So somebody on the team was like, hey, we have a 20-minute build. And what he said is, I'm going to just set all my Ruby Enterprise Edition GC settings to something crazy, just insane values, right? And basically say, like, okay, never run garbage collection. That's the point of setting these numbers all so high. Because during the test, you don't really care about garbage collection, right? RAM is pretty cheap. I've got 8 gigs on this thing right here. So why not just essentially turn it off for the entire time you're running the tests? And that changed, that one thing cut a 20-minute build down to 10 minutes, which just flabbergasted me. I never really thought about it. But if you do think about it, like what you're doing is all you do in tests is create a bunch of objects and then just drop them on the floor, and then create a bunch of objects and just drop them on the floor. And Ruby, being the good citizen that it is trying to pick up all that memory for you, right? But you don't need it, right? You're just going to run the tests and be done with it. So screw it. Set the things all really high, and then you'll run fast. Obviously, you probably don't want to do that in production. Graph your system, CPU, I/O performance, and look for opportunities, right? So all of these things are addressing different little bottlenecks you could have, but ultimately you want to kind of invest in some good sort of graphing tooling so that you can look at what's going on to your CPU, your I/O, your network over the time of your test, and look for things where like your CPU is just idle. Why is your CPU idle? Well, probably something else is going on that's really intense. And you see a bunch of I.O. stuff, and sometimes you can figure out what's going on just by looking at the graphs. Detour. Follow this guy on Twitter. See him talk if you can. There's a link to his Go Roco talk. He is passionate about this stuff. He's the sort of guy that won't stop until I think his test suite runs in 16 seconds now, and it used to run in like 20 minutes or something crazy. So he's like really into full bore going after this stuff, and I've talked to this guy. He's great. Please, if you're interested in that sort of thing, do pay attention to what he's doing, because he keeps coming up with new and better things to make tests speedy. Okay, silver bullet time is over. We need to have a little talk about your tests, right? Like, the previous solutions were all sort of happy fun time, like everything's okay, but now we need to say, like, what are you doing in your test suite that you probably shouldn't do? Keep in mind, I used to suck at writing tests too, right? Writing tests is a skill. You should get good at it. But when you first start, and especially if a team is new to adopting tests, you're probably going to write a lot of really bad tests, and that's okay as long as you clean up your mess. And that's pretty much a metaphor for all programming, right? Making mistakes is fine, but you have to go clean up your mess. So, mocking, the cause of and solution to all your test problems. So mocking is pretty controversial, and I think it's mostly controversial because like testing, like pair programming, like a lot of things that people don't like after trying for a couple of days, is you need to give it some time before you get good at it. Like the first year I did mocking, I'm pretty sure I was terrible at it because I was self-taught. It's helpful to have somebody around who knows mocking and stubbing and when you should stub and when you should mock. Even if you hate mocking and you think it causes more problems than it solves, you should realize that it does save a lot of time, right? Like, if you mock out calls that would normally go to the database, you're making something that was maybe a half-second or a second-long test. Now it's into the tenths or the hundredths of the second, right? Because you're just totally isolating this test. It's becoming much more atomic and a unit test. Stubbing is a little bit less controversial, right? That's the case where now you're saying, like, okay, I got to make an API call off to Google. Like, don't do that in a test. I mean, there's two huge reasons. One, it's crazy slow. Two, your test could fail because of stuff that isn't under your control, right? Like if there's a network hiccup and you can't talk to Google or you can't talk to some other, even internal API, right? It doesn't matter to you, right? That's not the test suite's job to find out what other people in your office or other people on the internet are failing at. Now, I've been in situations where I've actually written test suites that just test our API. So like our regular test suite is completely isolated from the outside world, but then we have another test suite that we run occasionally that tests like the things that we assume work, right? And we would oftentimes be the guys, when I was working at Vonage, we would be the guys who would go to some other team and say, by the way, like your telephone number lookup service isn't working. And they're like, what? I'm like, how did you know that? Because it's broken so many times we wrote a bunch of tests for it, right? And then we run them against your code. But stubbing out the expensive stuff, there's a lot of times, like if you're doing something with paperclip and, you want to test that and all of a sudden you're moving a bunch of files around on the operating system, don't do that. Stub all that out. Assume paperclip works, right? Somebody else's job is to figure out if paperclip doesn't work. Before each waste my time. So, I love this new nested thing that you can do with shoulda and rspec, right? You can say oh, I've got a little describe block, and then I've got another one inside it, and I got another context inside it, and each one of these guys can have a setup. And every one of those setups gets run every time. And how many times have you been inside some test, and you're like, what the heck? They set up all this stuff, but they don't use any of it. Every time you create one of these objects, that takes some time. So be very careful of sort of large setups that set up lots and lots of objects, and then the next developer in is just going to throw in a test, and he might just, not use half those objects, and then before you know it, you've got 10 tests, only 2 of which use the object setup in the setup. So keep that in mind, the don't abuse setups, and one of the fun things about this is that when you run tests in TextMate or from the console or wherever, everything seems pretty fast compared to Rails startup time, right? Like when you run the test, you got to load Rails environment, so you kind of wait around for a little while, and then the tests run, and then it's done. And the actual comparison of the test length to the startup time seems pretty trivial, but you might have a 2-second test or a half-second test and not really notice the difference. You should be paying attention to those numbers, right? It'll print out like how long the test took after it loaded the environment. And you want tests to generally be very fast, right? 1/10 of a second is a good unit test. 1,000th of a second, even better. Something else I should point out is that a test that needs a lot of setup is trying to tell you something. And this is something that gets forgotten about in testing, is that tests are not just about fault isolation and confidence. They're great at that, but they're also about design. So the idea of testing is you are writing an interface to your object, and that object, think of it as having an API. And when you're writing a test, you're actually thinking about your object from the outside in. So you're saying, how do I want to interact with this object? And then you create the object. That leads to better design. However, if you need like a huge amount of setup to just to test one little thing inside, say your controllers are always the biggest offender of this thing, then you're probably doing it wrong. You probably are doing way too much in your controller or whatever object you're in. Maybe you need to think about pulling some stuff out and segregating your objects a little better. ThoughtBot. I love that name, ThoughtBot. And I just like to picture ThoughtBot as being like this. Like, just a bunch of guys who dress up in robot suits for fun. ThoughtBot created Factory Girl, and it's awesome. But it's too damn awesome. Because what you can do is you can say something like, well, I worked at Groupon for a little bit, and the Groupon object is this huge object that can have like discussion boards, and people have purchased it, and people haven't purchased it, but they're about to, or they purchased it, but they haven't been charged. And like, if you say like, hey, give me a new Groupon, you get this huge object, and then it has like 16, 20 other objects that are attached to it, and they all get created, right? Because you can set up Factory Girl to say, when you create this, create these other things. And then that thing actually creates another thing. So what you would see is just this really innocent little line that would say like, factory Groupon, create. And you'd say, oh, cool, that doesn't seem like it's doing much. But it would actually take a couple of seconds. So a solution to this is to kind of keep an eye on the small, medium, and large rule. Generally, when you have Factory Girl stuff, you want something that is like a really small object, that is like just the minimum required to pass the validations. And most of the time, you can get away with that guy. And then the medium and large is when you need the large is when you need to really test the heck out of this guy. Like you're really looking at like, does the forum that is created, is it right or whatever. Which leads me to the next thing, create versus build. If you just build it, you save yourself a bunch of time, and the tests work just as well. So I think purely going through your code base and looking for create versus build, you can save a ton of time in your tests. So this leads me to the discussion of something that I was discussing previously. If you start parallelizing and getting really tricky with your test suite, there are advantages, but there are also disadvantages. You've just added a layer of complexity. So I know the people who get really into tricking out their test suite, keep in mind, everybody who joins your team is going to have to figure that out. And when it breaks, there better be somebody on the team who knows how to fix it. So every little bit of complexity is sort of a trade-off in terms of somebody has to fix it, somebody has to maintain it. Maybe you want to just focus on having fast tests without all the extra trickiness. There are some advantages. My favorite way to do this, because if you look at a test suite that's really terrible, is the adopt a test program, right? You just sort of use some profiling to figure out which ones are the slowest ones, and you kind of have a hit list on the wall, and you just sort of go, well, whenever I have some spare time, I'm doing something else, or I've finished a task and I'm looking to do something else, or maybe I'm in the code that's actually being tested by these terrible and slow tests, just start, going in there and saying, oh, well, they're using build or they're using create when they should have used build, or their setup is completely ridiculous, so let's make this a little better. Because if you try to do it all at once, it's just daunting and the business almost never goes for it, right? If you pitch, hey, we're going to spend a week making our test suite faster, I I don't know too many businesses that are going to be all right with that. So all this gets to my point of you should be thinking about a test speed as you write it. If you're not, it's pretty easy to just sneak up to a 30-minute test suite. I've seen it happen before where everybody is totally down with testing, everybody's really cool, but nobody's thinking about speed, and before you know it, we're all spending a lot of time on the internet. So, tests are supposed to lead to better design. Are yours? I know I've said this before, but it needs to be said again that you're missing a huge part of testing if you're not thinking about the outside-in design approach, right? That it's one of those things that everybody claims. Everybody like me who stands up and talks for a living says testing leads to good design. It's not by magic, right? Like it leads to good design if you use it in such a way that helps you, like if you heed the warnings that tests are giving you, right? When you have a huge setup, that's telling you something. So now what I'm going to do is I'm going to take a few questions and I'm going to move on to another topic.
Is the microphone working? Okay. A question about when you're talking about testing external APIs. For example, you need to get something from a Google API. Mm-hmm. And of course, at some point in your tests, you've got to have the case that the API is working correctly and the case that the API is not working correctly.
Yes.
And so how do you integrate that into your tests and do that speedily?
So I just sort of stub out the calls, right? Like, so I do a little of experimenting and I go like, okay, what happens when, this API call fails, right? And then I just basically stub out the test and either make it like, stub out the call and make it either like throw an exception, like a lot of times it'll be sort of one of those internet exceptions that you get all the time. There's lots of them. And then you also, basically test for when it works and when it doesn't work. And you figure out as many ways of when it doesn't work as possible, but you stub out all those things. And then you could have a separate test, a separate suite that maybe runs a couple of times a day or once every night that basically goes there and makes sure that your assumptions are true, that when you pass it X, you get back Y. Does that answer your question?
Yeah. I think what I was wanting to get at is, do you make a separate test suite for that?
Completely different test suite. I do not want anything in my test suite that I run before I check in that could possibly fail and it's not my fault. Right? I don't like that at all.
Yeah. Any others?
So it's a little bit related to the previous question. So eventually, even if you make your test suite very, very fast, it still will grow like kind of big enough and will take some time, especially if you do not only unit testing, but also like integration testing, and then you build a whole system and test it as a whole.
So, okay, I tend to lean towards unit tests because I like speed. And I feel like integration testing generally is the sort of regression testing. That's sort of like an automated suite that I don't run all the time before I check in, mostly just for speed reasons. I can't do it. If I'm going to have big cucumber tests that do lots of things and test everything really well, they're very useful, they're very good, but maybe that's a separate suite. Like I've been on projects where like you check in and we run the fast suite first, and then we run the slower integration suite second. Because if you have, if you're really going to full stack test things, it's very hard to stop things from getting kind of slow. Nick, who I showed you earlier, is actually, he claims that he's running, I'm sure he's telling the truth. He runs a lot of full stack stuff. He's just tuned his system so that everything goes pretty fast. The other thing is, sometimes the test suite gets really big because you should probably split your project up into a couple of different things. I mean, people say this all the time, but it's true. Like, it's better to have 3 small projects that talk to each other than one monstrously huge project.
Okay.
Does that answer your question?
Yeah.
Any other?
Okay, so awesome story. So earlier today, I was sitting right there, and somebody turned to me, and he said, "Hey, you have an hour time slot." And I went, "Really? I didn't know that." There's this whole trend in conferences to like move to shorter talks, and I was like, "Oh, 30-minute talks, cool." And so I'm going to talk about something else now. So, like I said earlier, I'm the metric foo guy. And I write this gem called metric foo, and it's gotten some attention, but I think it mostly falls by the wayside a lot because people don't really know what to do with it, right? It's like, hey, you could use metric foo to figure out if your code is good, right? Metric foo combines a bunch of things together, and it's code that analyzes code. And I'm just a nerdy guy, and I think that's really cool, right? Like you have like this thing like flog that looks at your code base and tells you where there's problems, which is kind of interesting. So this talk is what to do with your code metrics. So let's say you go through the trouble of doing gem install metric foo, and you run rake metric sol, which is this rake command you get when you install metric foo. And it can be run on Ruby projects or Rails projects, and metric foo is reasonably intelligent. It'll figure out if you have a Ruby or a Rails project, and it'll run different things. And you'll get a whole bunch of reports, right? You'll have flog, flay, cycro. I used to pronounce it cycru, but then I was told that it's actually a joke about cyclomatic complexity and it's supposed to be pronounced cycro. Anyway, reek, Rails stats, Rails best practices, archive, and churn. We've added a lot over the 2 years that metric foo has been in existence. And I think it's a little overwhelming, right? Because now you have all these wonderful graphs, and we graph over time too, right? So like every one of these things, if you set it up to run on a daily basis, we'll create a data point. We serialize this all the information to YAML, and then we can graph this stuff over time. So you can watch your complexity go up, or you can watch it go down after you do some refactoring. And it's pretty cool, but it's also pretty daunting, right? Like a lot of people just get this thing out, and they do this. They check the results, they get depressed, maybe they set up continuous integration, and then they forget about it. And this, I've seen this before, right? Like people say like, oh yeah, we've got metric foo running, and like, when's the last time anyone looked at it? And it turns out like the build stopped running because it's broken 2 weeks ago. Nobody noticed. Oh well. Bad programmer. However, I understand, right? It's a lot of information. So, time for the tour. Let's start easy, flay. So flay, written by Ryan Davis, is a structural duplication detection system. What does that mean? It means that it's looking for violations of dry. It's trying to detect copy-paste, but it's actually pretty intelligent. So flay can see through things that are surface different. So if you use curly braces or you use do end, it doesn't care. It sees that as the same. So it's actually intelligent enough to like be able to spot things where even though you've copy-pasted and then changed some of the variables inside, the names, it'll still say, oh, you're doing pretty much the same thing. I call bullshit on that. So very cool, right? So you get these reports that say like, hey, you've got a lot of duplication between these 3 files or these 5 files or whatever. And the solution for that is the same solution you have for any time you have a dry violation, right? Probably extract method, or you're thinking about a module that you're going to mix into a couple of places. And all this seems small, but it really is amazing when you try to add new functionality, right? Like, I don't know if you've ever been in a code base that's sort of gotten itself sort of sorted out and pulled things apart. But as a developer, if you follow the single responsibility principle, if you make sure that your methods really kind of do one thing and have one reason to change, the awesome part about this is that when it comes in to add new functionality, now you've got a set of Legos, right? And you can just put them together in ways that you want because each method just does one thing, right? And that's pretty cool. So, flay is one of the easiest ones to sort of figure out how to use and how to deal with, right? You just say, oh, there's duplication. Let's figure out how to extract it. Churn. So I wrote churn, and then actually somebody extracted out into gem. Good for them. Churn is just basically this thing I was thinking about, like, if things change a lot, that can be signs of interesting things. First of all, you want to know where your volatile code is, right? There's certain bits of code, and you know and I know, they change all the time, right? It's really active. The business is really interested in that area of code, and you're changing it. If you have volatile code, it better be good and well tested, right? If developers are going to be in there all the time, including your junior devs on the team, and it's very complicated code, you're just asking for trouble. Right? Like, because somebody's going to go in there and not really understand it, and then they're just going to make a change and it's going to get busted. And bugs tend to hide inside complicated code. So if you have volatile code, hopefully it is very good code. The other thing about churn is it tells you where God objects are, right? So maybe you have some object that whatever you do in the system, this object has to change because it touches everything, right? That's a God object, and that's kind of bad. You should be breaking that object up into smaller objects. CSS files show up a lot, which I think is kind of funny. We don't really refactor CSS so much, right? It's something you should think about, because if you have like this file that changes like 15, 20, 50 times every 2-week iteration, right? Somebody's always going in there. It's kind of a problem, right? Because you can easily sort of get sort of a bloated CSS file because people just don't even know what's going on anymore, so they just keep adding more and more stuff. Common metric foo problems. So the hardest thing about metric foo is archive, because everything else is static analysis, right? Like flog, flay, blah, blah, blah. They don't really do anything except look at your code, right? Static analysis. Archive runs your tests, and running tests is not super easy, right? And the way metric foo has to kind of do it is it shells out to the command line, and then it just runs it and tries to capture the output. And a lot of people have a lot of tricky stuff going on in their test suite, and it doesn't really work. There's ways to get it to work, but it's one of the number one things I get questions about. Like, I just can't. Or archive will fail, and it looks like something else is failing in metric foo. So I recommend, if you're having troubles with archive and you can't get it to work, just turn it off, right? In metric foo, you can configure any one of the metrics to not run. So, maybe fight that battle a little later, because I've seen people kind of get frustrated by it and then just stop using it. So let's pretend you got archive to work. Boy, I was really thinking about ripping archive out of metric foo, but I really need it for something I want to do later. I'm going to discuss that towards the end. Coverage, code coverage. So I think you've probably been exposed to the idea that just because you have high code coverage doesn't mean everything's great, right? High code coverage is nice, but it can be crappy code coverage, right? Like how many times have you seen something and it's tested, and then you look at the test and you go like, hey, all it really does is call the method, and that's it. It doesn't really even assert anything. So it's really checking to see if it just blows up or not. And that's not much of a test. It's a test, I guess, right? But it's not really a great test. And you see that sort of thing when people are new to writing testing, or even worse, when they have a manager who cares about coverage. That is a very dangerous thing, right? Because if a manager is walking around going like, oh, our coverage sucks, you can just basically get people going like, well, I'll get the manager off my back. I'll just write a quick test to cover it, right? And writing tests just to achieve coverage, you can write some really crappy tests that get you a lot of coverage. So where you need coverage is the places I was talking about before, where you have high complexity and where you have a lot of churn, right? Where you have a volatile bit of code. Writing tests just for the sake of coverage, I consider that harmful, right? You don't want to write a test for something that you don't understand because you might be locking in a bug. I've seen this happen before, right? Like you have a method and it's got a bug in it, but the person goes, oh, it's uncovered, I should write a test for it. So they see what it does, they check its output, and then they lock it in, but the output that they're locking in is wrong. So then the next person who comes along goes, wow, they have a test just asserting this. It can't possibly be wrong, and it causes a lot of confusion. If you don't really understand what the method's doing, you probably shouldn't be writing a method for it. And that's kind of like the adopt a test program, right? The adopt a method program is, if you're going to write some tests for a method, you should either be working inside it and know what it does, or you spend the time to figure out really what it's doing. So you write tests when you're in the code and understand it. So flog and cycro. So both are complexity measurement. Cycro is cyclomatic complexity. That was a huge thing in the Java world where I came from, but not super huge here. And the idea is just how many paths go through a method. So if you have a method and there's a couple of if blocks, there might be 5 ways through the method. There might be 10 ways through the method. And less ways through the method, right? So like if you get to a point, you branch off, and then there's another branch, and there's another branch. Ruby, it sneaks up on you, right? Because you can do these really cool things in Ruby where you just you write a bunch of stuff, and then at the end you say, unless, blah, right? You've just created a branch there, but it doesn't look like a branch because you don't have an if-else there. So ternary is also pretty popular, and there's just all sorts of stuff where you can have way more pass-through method than you really realize. Generally, you want to keep those amount of pass as low as possible so that when people go to alter it, they don't get confused and manufacture bugs. Now, Flog takes sort of a different point of view. Flog uses not just branching, which is all cyclomatic complexity is, but also assignments and calls. So Flog basically says, let's set up an arbitrary scale. And every time you do an assignment, like you say, x equals 1, I'm going to give you some points for that. And then if you do a branch, I'm going to give you some more points. And if you do a call, I'm going to give you some more points. A call would be calling a method. And it also kind of does some interesting things where it says, if you call eval, that's not the same as calling puts. So it knows some of the dirty tricks of Ruby and where the complexity lives, and it punishes you for using them. Now, that doesn't mean that using eval is forbidden and you can never use it, but it does mean that it's a little bit more complex, and it should be penalized a little bit more. So anyway, it throws a bunch of arbitrary points onto every one of these things, and then it sums it all up and it gives you a score. Now, the problem with Flog, even though I really like it, is that the numbers are arbitrary and nobody knows what to do with them. When I say cyclomatic complexity of 7, you go, oh, there's 7 paths through the method. Okay. Well, what does a Flog score of 102.68 mean? So over time, I've sort of developed this sort of shorthand. Now, keep in mind, this is my opinion, but generally, methods that have a Flog score below 20 are great. Between 20 and 40, it could be good, could be bad. 40 to 60, now you're getting into dangerous territory, right? You've written a bit of a complex method here. And then above 60, you probably can pull this guy apart, right? This is now a method that probably is doing too many things at once, and there's probably seams in there, right? You go, oh, this first part's setting something up, the second part's processing it, and this third part is sending it off through an email. Maybe that's 3 methods. So how do I fix it? So mostly extract method, right? Like I just discussed. Extract method, you just pull things out. Sometimes I miss the days when I was working in Java because extract method was really easy in IntelliJ. Does anybody use RubyMine? I don't know. How's extract method going in that thing? Is it?
Similar to the one in Java, but some cases it can't really extract it.
Yeah, that's kind of what I remember, is extract method's a little hit or miss automatedly. But that's okay, you're intelligent people, you can figure out how to do extract method manually. Missing object is something that I see a lot, right? You're doing all this complexity and you're storing it in a hash, which has an array, which has a hash inside it, because you're just going oh yeah, I'll just use the data structures that are available to me. And now you just have to remember in the third place of the array I have this. Maybe you should just make an object. Maybe you just should have an object that knows how to handle all this stuff, right? If you're doing all sorts of complicated stuff with telephone numbers, maybe you need a telephone number object, right? Because at Vonage, we did crazy amounts of stuff with telephone numbers. So we had a whole series of objects that just knew how to do telephone number stuff. Not something you'd need in most apps, but in that particular domain, totally necessary. Now, if you still can't get to the point where you're getting these methods low down, maybe you need to think about re-architecting how you have this. And that's more of a higher level thing. You have to sort of sit down and go maybe all these objects I have interacting with each other was a good sort of metaphor for the system once. But keep in mind, systems change, right? Your metaphor that worked perfectly well doesn't necessarily work in the future. But seriously, Like, you really shouldn't have to have crazy complex methods, right? If you're spending time doing the design, and design is everywhere, right? Design is not up front. Oftentimes, the most design I do is like, I'm in some method, it sucks, I turn to my pair, he's like, yeah, this sucks, and I have no idea, and I go, okay, team meeting, right? And we all walk over to the whiteboard and we just start drawing on it, right? That's to me how you do design, right? Like, the design up front, bad. However, that doesn't mean you don't ever do design, right? It's okay to draw boxes and lines between the boxes. UML is not the devil. It's kind of helpful sometimes in its place. Okay, Rudy, and Rails best practices. So these guys are interesting little, just weird, cool animals, right? They basically parse the code and try to figure out common design problems. So Reek or Rudy will sometimes say to you, hey, you have feature envy, right? Like, I don't know if you know what feature envy is, but the idea is if inside an object you have a method that references some other object more than it references itself, maybe you have feature envy, and what you should do is maybe just push that logic into the other object, right? If you were doing all these operations on object X and you're an object Y, why is it happening here? It should happen over there. Right? And so they can do things like say, oh, you're calling this thing a lot, so maybe you should do it somewhere else. That's great, because when you see the report, you can see something like, oh, I have feature envy. Like, I'll go look that up and see how to like fix it. Or if you know what it is, then you can just think about it. The bad side is, keep in mind, it's a machine trying to tell you about a human problem, right? Like, none of these things is a problem for the computer. The computer reads the code just fine. All of these design problems are about trying to make code understandable to you, humans. So all of these metric things need to be sort of taken with a grain of salt, because they may be wrong, right? Like, I've seen feature envy go like, oh, you have feature envy. Well, why? Because you call params, you talk to params all the time. Well, yeah, I talk to params all the time. It's a Rails project, right? Like, of course I'm going to ask params a bunch of questions. So I don't think that's really feature envy. Or sometimes they just have opinions. Like, I think Rudy will throw up a little error and he'll say like, hey, you used assignment inside an if block. Well, wait, I use assignment inside an if block all the time. I say if X equals, and then I like set something up because I want to use X later. Right? And I think Rudy's taking the opinion that you may have made a mistake. You meant double equals instead of equals. But as the team becomes more advanced, I think it's perfectly acceptable to use single equals inside an if block. A lot of these guys are configurable. So you can configure Rudy to not check for these things. So this is a decision for the team, right? And it also depends on what level your team's at. I've made the mistake of sort of assuming coding practices that I used on my last team are acceptable on my new team. And that is a bad mistake, right? Because I've been on projects where I've had like rock stars like on the team and checking in, and they're amazing, and they all go to conferences and speak, and they're Ruby gods, right? And then I've also had teams where like it's a bunch of Java programmers who just learned Ruby. And those are two different teams. And so, what is acceptable in one team is totally different than what is acceptable in another team. Yes, their advice, right? And that's the thing is like, I just said earlier, because I'm a passionate guy, that if you have a flog score over 60, you have a problem and you got to go fix it. But keep in mind, like, I have seen times when high flog scores can be refactored to lower flog scores, and you've made the code worse and harder to read. Like, I had one method where, like, I asserted a bunch of things that were equal to each other. And it was like the same thing over and over again. I was like, hey, is this equal to this? Is this equal to this? Is this? And it was like a high flog score. And I could refactor it using inject, and I got it down to like 3 lines and a low flog score, and it was completely unreadable. Like, I had written it 10 seconds earlier, and I was still kind of scratching my head like, well, I know this works, but like, the next time I'm in here, I'm going to have no idea what it does. So this is all advice, right? Like, it's a machine trying to help you solve a human problem. Doesn't mean it's always right. So let's talk about the future of metric foo. So metric foo is a little over 2 years old. It has gone from being a series of rake tasks, and it was a Rails plugin that had a series of rake tasks, and it was all written in rake. And we refactored this all out to create models, and it now runs on Ruby, and it creates graphs over time. It serializes all the output into YAML so other people could consume it. Nobody does, but if you wanted to consume the output of metric foo, you could. I want to fail to build on bad metrics because everybody wants me to. I worry about this because, like I said, this is advice. It's not for sure. So if you fail to build on bad metrics, it's not the same as failing a unit test. A unit test is supposed to be definitive. Something's wrong. But I keep getting asked for this, and I think I'm going to do it because why not? You know, it's the spirit of Ruby, right? The whole idea is that we trust you as programmers to do things, right? That's why we can let you call private methods if you feel like it. Because we say, well, maybe he's got a good reason. Coming later, metametrics. So imagine this, right? A report that could tell you that you've got some method that has problems with churn. In other words, it really changes all the time. It's terribly covered, and it has high complexity. That would be an awesome report, right? There's some guys out there who tried to make money off of metric foo. They tried to create a sort of a subscription service that didn't really fly. But they were actually kind of starting to do this, and I keep begging them to give me the code so I can get it back into open source, because I love the idea of hotspots, right? So you can sort of combine a couple of metrics together. The trick of this is a lot of the output has no idea about methods. So the output of, say, rcov is just a bunch of lines, and it says this line was covered or this line wasn't covered. It doesn't say this method was covered or this method wasn't covered or this class, right? Because it doesn't know classes or methods. It just knows lines. So what you'd have to do is either read the output and turn it back into classes and methods, or probably better yet, adjust rcov so that it could output coverage per methods and classes, which would be really cool. But it means you have to convince rcov to accept that change, and then somebody has to write that change. And then you have to do it for Reek and Rudy and Flay and Flog and all that. So it's not particularly easy, but it's something I really want to do. I think it would sort of help out a lot. It would also make things simpler, because instead of having just the main page of metric foo, let's see, this is what you get when you do metric foo. This is me running metric foo on itself, which I do all the time, because first of all, I think it's funny, and second of all, it's very helpful. So, you get these all these graphs and stuff, and it says oh, here's your average, and you click around in here and you say, ooh, let's see what's going on with Rudy. Oh, okay, let's see. My cyclomatic complexity is kind of high, okay. And what's going on with Reek here? Ooh, low cohesion. Well, that's a problem. It's kind of hard to read all of this stuff, right? It'd be really cool if on the front page I just had something like, okay, here's all the reports, but up top you have something where here's the things you need to address now, right? Here's something that has a lot of problems in just one class or in just one method. So this is where I say hey, this is open source and it's on GitHub. How would you like to help? See, that's where I said help. Resources. Okay, so nope. So yes, this is the metric foo homepage. We got a Google group, we've got GitHub, we've got an issue tracker. We're just using GitHub, and then there's my blog. I've got some documentation here. Nobody likes writing documentation, least of all me. I try to write as much as I can. I'm always looking for help, because some of this, I will admit, is kind of out of date, right? I know how to use metric foo, so it's very hard for me to write descriptions of how to use it. Anyway, I'll get back to I hate when people just spend the whole time begging for help. I think this is about it. Yep. So, time for questions.
I actually had an experience exactly as you described in one of the first slides, where we had the metric foo installed and used it for like a couple of weeks, and then everybody just forgot about it.
Yeah.
And I honestly don't know what's going on there right now. So could you give us some examples of like success stories where you could actually integrate usage of metrics in like everyday development in some project or whatever?
I can tell you what I do.
Obviously, you do it yourself.
Here's
but
how I do it.
How could you make other people on the team use it?
Okay, how do I make other people do it? I don't know. I have yet to succeed. How about that? I tend to check it there tends to be one guy, right? There's always like that on teams, right? There's one guy who cares about X, right? And I tend to check it, every couple of days or every couple of weeks. Depends on how much we're doing, right? If we just did a huge refactor, I'm checking it a lot to see what's going on. If we're not doing huge changes, I'm checking it less often. And I kind of create like a hit list of methods. So I kind of have like a list on, like I just write down like, I hate this method. I hate it. It's always at the top of the flog. It's always at the top of flay. Like, it's not very well covered. And I'm just kind of like going after that method in my spare time. Or if it's big enough, like I'm starting a story. Like I'm basically saying like, here's something we did recently. So we use JQ Grid, and it basically creates these neat little grid objects that like do a lot of querying in the database, and it's kind of wonderful. But it was implemented 12 different ways in 12 different controllers, and it was horrible, right? Like every time we had a bug, we would fix it in 3, but not the other 9. So I was like, and you could just see this all over metric foo, right? Like it was just, there's this flay problem, right? Like, and I basically said, like, we have to pull this out into one object and just make this do the same thing everywhere. And I got my manager to, put that into the iteration, and we did a story on it. So, you can generate stories out of this, right? The story could be refactor class X so it sucks less. I'm sure there would be an actual different story.
But basically, for smaller changes, you just go yourself and fix it yourself.
If it's less than 15 minutes, I just do it. It's better to seek forgiveness than ask permission in a lot of those cases. But big things, I really want to, I don't want to subvert the agile process. There's too much of that going on anyway.
Thank you.
Other questions? 日本語で OK です。よ。よ。
Okay, thank you so much for spending some of your time listening to my talk.